Hello and welcome back to our today's lesson, and today we are going to plot the bending moment diagram as well as the shear force diagram for a fixed beam that has also got a clockwise moment on the span B to C. And please, ladies and gentlemen, if you are here and you are ready to subscribe, please consider subscribing to this channel for more and more structural engineering videos. Now, we are going to begin with determining or calculating the maximum bending moment between the span A to B. And on the span BC, we are going to determine the bending moments at the point D. And therefore, we are going to begin with the span A to B. Therefore, for the span AB, the maximum bending moment will be given by this formula, WL1 squared. We divide this by 8 since the span AB is loaded with a UDL of 6 kilonewtons per meter, and this is going to give us a bending moment of the span on the load, which is 6 kilonewtons per meter, multiplied by the span L1, which is 10. So that's going to be 10 squared. Then we divide this by 8, and when we do so, we are going to get 75 kilonewton meter. So that is the maximum bending moment between the span A and B, 75 kilonewton meter. Then from there, we go to the span BC. So for the span BC, beginning with the left hand side, on the left, we are going to have a bending moment at D, which will be given by the clockwise moment at D multiplied by the distance from B to D, which in this case will be denoted by A, divided by the whole span from B to C, which is 7 meters. And this is going to give us a bending moment at D of 120 kilonewton meter, that is the clockwise moment, times the distance from B to D, which is 4 meters. Then we divide this by 7. And when we do so, we are going to get 68.57 kilonewton meter, which is going to be a negative bending moment. So when we calculate the bending moment on the left hand side of the point D, it is going to be a negative bending moment. Then from there, we determine the bending moment on the right hand side of the point D, and that is going to be given by, therefore, MD will be given by the clockwise moment at D multiplied by the distance from D to C, which is in this case is B, and then we divide by the whole span, which is L. And this is going to be the clockwise moment, 120 kilonewtons meter, B 3 meters, and the whole span 7 meters. And that is going to give us a bending moment of positive 51.43. 51.43 kilonewton meter. So those are the values of the bending moments that we need, and from there we are going to plot the bending moment diagram due to the loads as well as due to this clockwise moment here. And beginning with the span AB, we have a maximum bending moment of 75 kilonewtons. And since the span is loaded with a UDL, we are going to have a bending moment diagram in form of a smooth curve. This is how it is going to look like. So we are going to have a smooth curve in that form with a maximum bending moment of 75 kilonewton meter. On the span BC, on the left hand side of the point D, we have negative 68.57, which will be plotted below this horizontal line, and let's approximate our 68 to be at that point. So the bending moment at D, that is 68.57 kilonewtons meter. Then we connect it, or we join it to the horizontal line. The bending moment at D on the right hand side, that is 51.43, and we approximate it to be here. This is 51.43. It is positive, and therefore we are going to plot it above this horizontal line, and then we join it to C. So this is a negative bending moment, that is a positive bending moment. Now, for a fixed beam, we must extend an imaginary zero span, or an imaginary span, beyond the fixed end A, whereby the supported point is going to be A naught and the span is going to be L naught. On this side as well, we are going to extend an imaginary span, which is also going to have an imaginary support, and at this point we are going to have C naught. The distance from C to C naught, that is going to be L naught. So that is when we are dealing with a fixed beam. Now, beginning with the spans A naught and A, therefore, for the span A naught A, the area of the bending moment diagram on that span, which of course we don't have, is going to be 0, and bar x naught is also going to be 0. From there we go to the span A to B. For the span AB, the area, which is A1, area of this bending moment diagram, will be given by 2/3 of its base, and its base is this span A to B, that is DC. A to B, which is 10 meters, so 2/3 of 10 meters multiplied by the height, which is 75 units. 75 units. So we got A1 500 square meters. Then we determine the value of bar x1, which in this case is the distance from the center of gravity of this bending moment diagram all the way to the end A. So that is bar x1. And in this case, bar x1 will be given by half the span AB. So that's going to be half of 10, which is 5 square meters. Now, A1 bar x1 will now be given by A1 500 square meters, bar x1 5 meters, sorry, not 5 square meters, 5 meters, since that is a distance, which is going to be equal to 2,500 meters raised to the power of 3. Then from there we go to the span B to C. So for the span BC, B being the origin, B as the origin, we are going to have the following: A2 bar x2 will be given by, let's call this triangle A, or let's refer it to as A, and the other one B. So it is going to be given by AA bar XA plus AB bar XB. Let's start with AA. That is the area of this triangle. And the area of that triangle will be given by a half multiplied by its base, which is 4 meters multiplied by its height, which is negative 68.57 kilonewtons meter. That is the bending moment at D on the left hand side. So multiplied by negative 68.57. And when we multiply a half times 4 times 68.57, that is going to give us an area of negative 137.14 square meters. Then we need the value of bar XA. Bar XA, which will be given by, this is the 90 degrees corner. So from the center of gravity of this triangle all the way to the end B, that distance will be given by 2/3 of the base of that triangle, which is 4. And the other part is usually given by 1/3 of the base. So the remainder being 2/3. And 2/3 of 4, that happens to be 2.667. That is 8 divided by 3. We get 2.6667 meters. A multiplied by bar XA will be equal to 137.14. So we got negative 137.14 multiplied by bar XA, which is 2.667 meters, which is going to be negative 365.7 meters raised to the power of 3. So that is the value of A bar XA. From there we go to AB bar XB, and we are going to begin with AB, and in this case AB is the area of this triangle, which will be given by a half of the base, 3 meters, multiplied by the perpendicular height, 51.43 units. 51.43 units. And that's going to give us an area of 77.145 square meters. Then bar XB, which is the distance from the center of gravity of this triangle all the way to the end B. It is going to be 1/3 of the base of this triangle plus the distance from D to B, which is 4 meters. So that is going to be 1/3 of the base of this triangle, which is 3. Then we add the distance from D to B, which is 4 meters. And that is going to be 5 meters. And therefore, AB bar XB will be 77.145 multiplied by 5. So that's going to be 385.725 meters raised to the power of 3. So that is the value of AB bar XB. Very good. So from there, we are going to add these two, A bar XA plus AB bar XB, so that we get the value of A2 bar X2. So A2 bar X2 will be given by negative 365.7 plus 385.725, which in this case is going to give us, so that is A2 bar X2 is going to be 20 meters raised to the power of 3. So that is the value of A2 bar X2. Then from there we go to the same span for span BC, and in this case C being the origin C being the origin, we are going to have the same A2 by X2, which will be equal to AA by XA plus AB by XB. So when we add the two, in this case C being the origin, we are going to get the value of A2 by X2. We have the area of this triangle, which is negative 137.14 square meter. By XA, C being the origin, will be given by a third of the base of this triangle, which is a third of 4. We add the distance from D to C, which in this case is 3 meters. Therefore, we add 3, and that is going to give us, after multiplying these two, we are going to have negative 137.14 multiplied is going to give us AA by XA being equal to negative 594.2733 carrying meters raised to the power of 3. So that's what we got. Then from there we go to AB by XB, in this case C being the origin, and AB, that is the area of this triangle, which we had gotten it as 77.145 square meters. Then by XB will be given by the distance from the center of gravity of this triangle all the way to C, which is 2/3 of 3. So in this case we are going to have 2/3 of 3, which is 2 meters. When you multiply the two, that is 77.145 times 2. That is going to give us AA by AB by XB being equal to 77.145 times 2, that is 154.29. 154.29 meters raised to 3. Then from there, what we are going to do, we are going to add these two values together. So we are going to determine A2 by X2 by adding the two values together. That is negative 594.273 plus 154.29, which in this case will be equal to A2 by X2 will be equal to negative 440 meters raised to 3. Therefore, ladies and gentlemen, we now have the values of A2 by X2, C being the origin, and we also have A2 by X2 with B being the origin. Very good. Then from there, we apply the three-moment theorem, and we are going to begin with the spans A0A and AB. And the formula is going to be as follows. We are going to have M0 L0 plus 2MA into bracket L0 plus L1 plus MBL1, which is going to be equal to 6A0 by X0 divided by L0 plus 6A1 by X1 divided by L1. And in this case, M0 L0, that is 0, so 0 plus 2MA into bracket L0 is 0 plus L1 is 10 meters plus L1, which is 10 MB. That will be equal to, this one is 0 plus 6 multiplied by A1 bar x1, we had it as 2500. 2500. Then we divide this by L1, which is 10 meters. So this is going to give us 2 times 10, that is 20. So we got 20 MA plus 10 MB is equals 1500. Then we are going to divide through by 10, and when we do so, we are going to have 2 MA plus MB is equal to 150. And that's going to be our equation 1. So we got our equation 1 there. From there, we go to the spans. So for spans AB and BC. Yep. The spans AB and BC. The three moment equation is going to be as follows. MAL1 plus 2MB into bracket L1 plus L2 plus MCL2, which will be equal to 6A1 bar X1 divided by L1 plus 6A2 bar X2 divided by L2. And this is going to be as follows. L1 is 10, so we are going to have 10 MA plus 2 MB into bracket 10 plus the value of L2 is 7 meters plus 7 MC, which is going to be equal to 6 multiplied by A1 by X1, that is 2500, divided by L1, which is 10 meters, plus 6A2 by X2, and in this case C as the origin. So we are going to have 6 multiplied by A2 by X2 with C being the origin, that is negative 440. So 6 times negative 440, divide this by L2, negative 440, divide by L2, which is 7 meters. And this is going to give us 10 MA plus 10 plus 7, 17 times 2, 34. So that is 34 MB plus 7 MC being equal to 1500 minus, since we have this negative here, so 1500 minus 377.14. 377.14. This is going to give us 10 MA plus 34 MB plus 7 MC being equal to 1500 minus 377.14, that is 1122.86. Then we are going to divide through by 10, by this 10, and this is going to give us MA plus 3.4 MB plus 0.7 MC being equal to 112.286. So this is going to be our equation 2. So that is our second equation. Then we go to the final spans, that is BC and CC naught. Our 3 moment equation will be as follows. We are going to have MBL2 plus 2MC into bracket L2 plus L0 plus MC naught L0. That is going to be equal to 6A2 bar X2, divide this by L2 plus 6 A naught bar x naught divide by L naught. This will give us L2 is 7 meters, therefore 7 MB plus 2 MC into bracket L2 7 L naught 0, that is on the span C naught, the 0 span, plus this part is going to be 0 is equals to 6A2 by x2 divided by L2. In this case, B as the origin. B as the origin, we have 20. So that is going to be 6 multiplied by 20 divided by L2, which is 7 meters. And this will give us 7 MB plus 2 times 7, that is 14 MC is equals to 120 divided by 7, that happens to be 17.14. 17.14. Then we are going to divide the rule by 7. So this will give us MB plus 2MC being equal to 17.14 divided by 7, that is 2.45. 2.45. So this will now be our equation 3. Then from there, we are going to make MA the subject in our equation 1. MA will be given by 150 divided by 2 minus MB divided by 2. And this is going to give us the value of MA being equal to 150 divided by 2, that is 75, minus MB divided by 2, that is 0.5 MB. So that is the value of MA. Now, the value of this MA, we are going to substitute it in our second equation. So we are going to replace this MA with what we got here. So that's going to give us 75 minus 0.5 MB plus 3.4 MB, 3.4 MB plus 0.7 MC, 0.7 MC, which is going to be equal to 112.286. 112.286. So we got minus 0.5 plus 3.4, that is 2.9. So we got 2.9 MB plus 0.7 MC, which is going to be equal to 112.286 minus, we take 75 the other side of the equal sign, so we got minus 75. So this will lead us to 2.9 MB plus 0.7 MC, which is going to be equal to 37.286. So this is going to be our equation 4. Now from there, we are going to solve the equation 3 and equation 4 simultaneously. Therefore, solving equation 3 and 4 simultaneously, we get this. So what we are going to do, we are going to multiply the first equation. We are going to multiply it by 2.9. So the first equation, we multiply it by 2.9. The second equation, we multiply it by 1, since we have 1 MB there. So this is going to give us the following. So we are going to have 2.9 MB plus 2.9 multiplied by 2, that is 5.8. So we got 5.8 MC is equal to 2.45 times 2.9, that is 7.105. 7.105. Then on the second equation, we are going to have 2.9 mb plus 0.7 mc, which will be equal to 37.286. Then we are going to subtract the two equations, and 2.9 MB minus 2.9 MB, definitely that is 0. 5.8 minus 0.7, that is 5.1 MC, which will be equal to negative 30.181. Then from there, we are going to divide both sides by 5.1. This side as well, we divide by 5.1, and that is going to give us a bending moment at C, bending moment of negative 5.92 kilonewton meter. So that is the value of the bending moment at C. Then from there, we are going to use the first equation to determine the bending moment at B, and we are going to do that by making MB the subject. So from equation 1, making MB the subject, MB is going to be 2.45 minus 2mc, and mc is negative 5.92 kilonewtons meter, and that's going to give us a bending moment at B 14.29 kilonewton meter. So that is the bending moment at B. From this equation, we have MA being 75 minus 0.5 MB. Therefore, the bending moment at A will be given by 75 minus 0.5 MB, and MB is 14.29 kilonewton meter, and that is going to give us a bending moment at A, bending moment of 67.855 kilonewton meter. Therefore, we got all the three bending moments that we were calculating, and we are going to come here and start with the bending moment at A, which is 67, assuming it is at that point. So we got 67.855 kilonewton meter. Then the bending moment at B, that is 14.29. We join that here. So we got 14.29. Then at C, we got a bending moment of negative 5.92, and it is going to appear below this horizontal line, and actually guessing it to be at that point. So this is why you have bending moment at C, which is 5.92 kilonewton meter. So we are going to join the 14.29 to the 5.92 kilonewton meter. So ladies and gentlemen, that is now our complete bending moment diagram. So from there, we are going to shade off the outline of our bending moment diagram so that it becomes very clear and the outline becomes visible. So that is how we are going to shade our outline, and please, ladies and gentlemen, keep on subscribing, comment, like and share, so that you give us the support to go on doing what we do best. So this is a positive bending moment, this is a positive, this one is positive, negative, negative, this one is negative as well. So Ladies and gentlemen, that is now our bending moment diagram. So thank you very much for watching our video. Please join us in our next episode where we are going to plot the shear force diagram. So thank you very much for watching.